Hello again. You don't want to experiment with real fires if you can do so with a model, unless you are me as a little boy, of course. This model here mimics a wildfire. There it goes. Patches are trees, and there are two breeds of agents, fire and embers. Fire can jump to neighboring patches that have trees on them. What would happen, would you think, if we increased the wood density in the model from 60%, what it is now, to 70? Well, it's a no-brainer, right? It burns more quickly, and it becomes more predictable where it will burn. But I'm getting carried away. Actually, I want to talk about the NetLogo code, in particular about synchronization of agents. You see, in agent-based models, there are usually many agents doing all kinds of things. For the result, it can matter a lot how the order of events is programmed. Let me give you a simple example from the NetLogo code of the fire model. I did something to that code. Here is the go procedure, the main action of each agent in each tick. In it, I introduced a yes-no switch named synchronized, ? When it's off, the program runs as before. You see that here. This is the normal code. Synchronized switch is off. The ask fires statement that you see asks all fires to ignite their neighbors and then to set themselves to embers. Each of the fires will do both things before the next fire has its turn until all the fires have had their turn, and then you get the next tick. When the synchronization switch is on, the order of execution is slightly changed. We see that here. There are now two ask fires statements. The first to ignite the neighbors, the second to set the fires to embers. All fires will do the first thing, then all fires will do the second. What would the effect of the model be? Does it make a difference anyway? Let's have a look. So we'll run the model with the switch on. No matter how dense, the fire refuses to burn. Why? And we only changed the synchronization between the agents, nothing else. So for creators of agent-based models, the lesson here is they have to reflect on which agents take which actions in the model at what moment and what are the consequences of those actions. And also for us as users of the models, we need to remember this. For now, you are just a user, but you may also start to build your own models or make changes to existing ones like I just did here. The NetLogo models library is there for that purpose. So why not give it a try?